Hi, welcome back. Thanks to Paul from Haxby Shed for having me a few weeks ago at his workshop. Thank you to all of the new subscribers that have come over from his channel. I suddenly got a deluge when he put his video out, so I hope you find this channel vaguely entertaining. Now, I don't always do CNC stuff. It's just that's what's taking my time at the moment. I've got plenty of other non-CNC stuff to look at, so there'll definitely be more videos that aren't CNC. Got a new toy. A friend of mine picked this up at a Steam fair. A little manual hand shaper, fits the bench. So that needs looking at, so that's a future video. In the last video I made a test piece to fit on the bearing for the end of this table. It's the bearing that supports the far end of the lead screw, not the driven end. And this machine didn't come with a table, didn't come with an end plate, so I'm trying to replicate the one which I've taken off the manual mill. I decided to do it in aluminium because it doesn't actually need to be steel, and in terms of learning to use the CNC machine, aluminium is a much safer bet. So I'm going to cast it out of this. This is a little pattern which I 3D printed. The idea being that this spigot on the bottom allows me to clamp that in the vise, and I've got full access to the perimeter without hitting the vice jaws. You'll see how well that goes shortly. The purpose of this is to get more of a feel for the machine, so I'm trying to figure it all out for myself. I've not got any experience with this, I'm just figuring it out as I go along. So let's cast this and get going. You also get to find out how long a 3D printed pulley and belt last. So I cast this piece mostly because I knew fairly certainly that it would end up not going 100% right, and I didn't want to spend real money on a piece of aluminium that was just going to potentially be a piece of rubbish. Started off just by cleaning it up so that it could be clamped in the vise, and then used the CNC mill in sort of manual jog mode to clean up the edges of the holding protuberance. Now, the intention of this was so that I could mill all the way around the perimeter without leaving a burr, and as you'll see later on, I completely forgot about that and didn't cut down quite low enough, and I did end up with a burr. So to face it off, I'm using my 4 flute 40mm face mill. Setting the height using a piece of paper. Piece of paper is about 0.1mm thick. Once it's pinched, we just set the Z height as plus 0.1. Now, I'm not showing all of this. I did do several passes with different settings to try and get the numbers dialed in. As you can see on this last pass, I just about got the values adjusted to get a nice mirror finish. So the top pass didn't quite work, but the bottom pass did. Again, this is just learning, so seeing what works, what doesn't, trying to take it all in. So this is the profile being cut, a bit of air being cut to begin with, just because it's casting. It's not exactly the size that it is in the CAD, so one edge is cutting more than the others just at the moment. It did all clean up. This is just cutting the profile. And using a non-roughing mill to clean up the perimeter, because the roughing mill leaves a bunch of lines on the surface. This leaves a nice shiny finish. And then plunging the hole for the bearing. This was the bit that I dialed in on the last video to get the size just about right. What I didn't do is get the depth quite right, so I had to go in again, as you can see here, doing it twice. They're just centre drills for the through holes and the chamfer around the outside, and finally popping a couple of holes in. setting the Z again, using the piece of paper, and then this time I used the drill bit to get my XY coordinates. It's not a very good way of doing it, but because I had an overhang on the material, I hadn't completely cut it away, I couldn't really use any kind of edge finder on the X direction. I could potentially use the jaws and the vise for the Y, but as you can see it's almost as long as that, so for the purposes of this it doesn't have to be completely 100% accurate. It's mostly just a learning exercise, and there's a new learning just here. That was quite a lot of movement. I think we've found the limit of these, which is a hell of a lot higher than I thought it was going to be. So maybe I better buy a real one of these. Although for now, I might have to just print another one to keep going. For the moment, I've printed a new pulley, and I've just finished printing a new belt, which will keep me going until I get a real one. So let's run the new tool path, which is slightly less aggressive than this one, and see what happens. That didn't work. So I don't fully understand why that happened. If I did, it wouldn't have happened. There was supposed to be a 1mm depth of cut, and it's about 2, so my Z offset must have been out, and even though I thought that it was right, it clearly wasn't. The other thing was, the spindle got to the work before it was fully up to speed, so I need to add in a dwell, so that when the spindle turns on, it sits there for a few seconds to spin up before it starts ploughing into the work, because obviously if it's not spinning fast enough, the chip load is much higher, and that's not going to help. So I've printed another set. This is the old one. I'm going to modify the cam again just to be even more conservative. So at this point I decided to take a look at the belt with the cover off. I hadn't done that before, and I think that might be why I had that second incident. As you can see, the belt is flapping around quite wild. I decided to run it anyway, just to see how well it performed, and it seemed to be okay for the first bit here, but as I got further and further down I really had to nurse it through, ending up going quite slowly towards the end. I think the problem is that it was heating up quite a lot. The spindle seems to be getting very hot, which is something else I need to look at, so I think the bearings perhaps need a bit of attention on there. Because it was getting hot, the belt was getting stretchier, and you ended up with a slipping belt. I think the reason the first one had lasted so long was because I'd started off very, very gently and progressively tightened the belt tension, whereas this time I'd just put it on, tightened it up, and took a very aggressive cut, and of course it didn't like it. So you can see that obviously I lost my XY position on several occasions. Didn't get it perfect because there's still a bit of a burr here where the chamfer hasn't cleaned up on this edge, and then this edge, the chamfer is quite large. That finish is pretty smooth. You can just about see a witness mark for the hole there. It's obviously very, very thin, and that's just a blowhole in the casting, same as that. I can clean that up with a deburring tool. Generally, despite the incidents, that's turned out fairly well. Should be able to bolt it on. Alright, moment of truth. Alright, so that's done after a fashion. It's not perfect, but it's perfectly functional, All it's got to do is support the bearing at the end of the lead screw there. Thanks everyone for watching, and I'll see you again next time.